to have.
Welcome to AWS OnAir.
I told you I'm excited about this.
We want to help you see the things that are new and launching.
We are throwing you into the deep end.
Day 10. Let's do it.
Hey everyone, welcome to another episode of AWS On Air. It's Friday afternoon, lunchtime over on the West Coast. It's about quitting time over on the East Coast where I am, but we are here again to talk about all the latest and greatest news and features, product releases, whole bunch of cool demos, what's new with AWS. I'm one of your co-hosts. My name is Jeff Marushak. I'm a senior solutions architect on our DoD Air Force team. And with me, I have a good friend of mine, Robbie. Robbie, say hello to everybody.
Hey folks, happy Friday. Robbie Belson. I'm a solution architect and developer advocate here at AWS, based in New York City. I guess based on what you were saying earlier, that's my end of week, Jeff. But there's no better way to close out the week. We've got a bunch of really cool launches to break down, an incredibly powerful customer story, a few new segments that we're going to be trying based on customer feedback. So a whole lot to cover. But folks, if this is your first time tuning into Twitch and AWS On Air, this is our weekly show. We're always breaking down new feature releases, customer updates, launches, and so much more. A show built for you. You tell us what you want to see, and we bring it to life. And we stream all week long with a number of really cool segments, from startups, security, game day with AM, and so much more. So really happy to be here with you again, Jeff. And I want to give a quick shout out to our US audience. I know we're on the Hero. I'm based in New York City. Where are you based again, Jeff?
I'm right in between Cleveland, Ohio and Akron, Ohio. So representing the kind of the Eastern Midwest.
So it's a big week for us. I mean, football is back. Whether you're NFL, into the NFL, which we'll get into, we got a special surprise for the audience, or college football. It's a great time to be alive, man.
Yeah, well, I mean, like I said, I am in the Cleveland area, so that means I'm a Cleveland Browns fan. So that means it's not that, sometimes it's sort of exciting, but we kind of, the realization comes in that we are the Cleveland Browns. So, who knows what's going to happen. But what I'm more excited about is that the summer break of Formula One racing is over, and the Dutch Grand Prix is happening this weekend. Really excited for that. So really, really good stuff.
It's going to be a great weekend. And tell us in the chat where you're coming in from, what you're excited most about this episode. And if you're an NFL fan or college football, tell us your team. Tell us who you're rooting for. And we'll try to feature one of you on the main screen here. But while we wait, let's jump right into our first segment. Jeff, I know we've got a bunch of recent launches to break down. What are we going to be talking about here?
Yeah, if folks have followed me around, they've known I probably say the term VMware a lot, because I was a big VMware guy before I came to work at AWS about 5 years ago. And AWS has really been pushing the boundaries of, what customers can do with their VMware workloads, whether it's migrate or whether it's run those workloads in AWS. And there's a recent service, EVS, that's coming out that we want to talk all about. So we have the service team and we have the folks that built that service to talk more about it and to tell you guys what it offers and how it makes customers' lives easier that are kind of wondering what's going on. What should we do with our VMware workloads? So
let's bring out the guests.
All right.
I told you I'm excited about this.
And with us for this first segment, we have Andy and Arthi. You guys, can you introduce yourself to our audience?
Yeah. First, I'll say go Cowboys, representing from Dallas here. So gotta get that in. Hey everybody, my name's Andy Reedy. I lead the product team within the EC2 organization that is responsible for the Elastic VMware service.
Arthi?
Hey everyone, go Chiefs. I am from Kansas, so go Chiefs. We'll get it again. Arti, I lead our engineering team for Amazon EVS.
Awesome. So we talked about VMware, and some of our folks, our audience, might not know what VMware is or what a virtual machine is. So let's start there. Let's set the stage. Andy, Arthi, I'll let you guys choose. What is VMware? We'll start there.
Yeah, so I guess the easy way to describe it is in the before times, before VMware. If you had an application and you needed to run it, you ultimately had like one application per server. So imagine like this server was a web server, and that's what it did for everything. About 25 years ago, VMware came onto the scene and they introduced compute virtualization, ultimately allowing you to run a bunch of virtual machines, entire virtual servers on a single piece of hardware. And so this is really proliferated. This is how most customers in on-premises data centers today run their workloads, is by running virtual servers operating on top of VMware.
So I guess the big question here, since we are AWS on air, and I have to pretend, Andy, for the next 20 minutes or so to be friends, because alas, I am a Commanders fan.
Oh,
But suspending disbelief here for a second, I think the question that folks who haven't had a chance to run VMware before would be saying, okay, well, why would I want to run VMware on the cloud? Is it that same value proposition of the cloud I know and love for, say, a traditional virtual machine on premise?
yeah, it really comes down to three things. You have kind of the people, the processes, and the technology. So people are running VMware on premises, and it can be really tough to move away from that. You have to retrain your people. Ultimately, you have to learn something new. You may have a lot of tooling. Imagine just like all the scripts and the processes and things that are built around that platform. And then the operational processes. What do you do when something breaks? And then the technology. All of the partner solutions and things like that folks use. So it's really hard to be able to change those things out. And so kind of the basics or the magic of EVS is that we allow people to keep that same platform, that same virtualization stack, but run that on AWS Metal infrastructure.
Yeah, Andy, I think there's a lot of times when people are kind of gossiping or kind of like being true to form, they'll say like, all right, well, kind of the next step, there was one application per server, and then there was like the virtualization kind of overhaul, and that kind of changed data centers across the country. And then cloud came around. So some might say there's like this progression from data center to virtualization to cloud. And then like, why would you want to run, but VMware in the cloud once you just migrate? But there are like you're saying, there's a lot of good reasons. So tell us what EVA is, and kind of why AWS developed the service, and how it helps customers.
Yeah, really, as we were talking to customers, the thing that became really apparent is that whole process of having to change things out during a migration adds just a lot of friction. Like the more, like anytime you change variables, right? Like it's work you have to do. You have to retest things. You have to validate stuff. And so what we really found is that we could help customers accelerate how fast they move to the cloud by reducing the amount of things they have to change between point A and point B. So EVS, since it's running the exact same virtualization stack that customers are using on-prem, it really makes that lift and shift a lot easier. If you can just kind of pick up everything on-prem and move it into the cloud without having to go change and retest a whole bunch of stuff, it allows you to go just a whole lot faster. So this is really kind of the magic. If you have a situation where you need to get out of a data center pretty quick, like I think I get a call like at least once a month where somebody's like, my data center contract's up in 6 months. Oh my gosh, what do I do? And that's the case where EVS is really magical, being able to like just fire up an environment that looks exactly like your on-premises data center, and just lift and shift everything over, and then be able to operate it in a very similar, if not the exact same manner as you did on-prem.
So I always like to say here at AWS on Air, Andy, that seeing is believing. And so if we were to jump into a demo, maybe in the AWS console, where in the movie are we? Are we in that, say, traditional 6 month migration? Are we towards the end of the migration? You're going to show us what it looks like in the console. Help orient us where in the journey, what we would be seeing, and what a sample customer journey might look like here.
Yeah, awesome. I can take that. So on the console here, what I'm showing is two things. One is how easy it is to deploy this VMware environment on AWS console. Andy talked about it. Traditionally, if somebody's doing this on premises, getting capacity, racking, stacking could take 6 to 12 months. But what we're doing is we're taking care of that heavy lifting for our customers. So as you can see here, the Amazon EVS is part of the AWS console. So on the screen, if I go in and say, hey, let's go ahead and get an environment created, I just put in some basic information, similar to how you would create an EC2 instance or an ECS cluster, for example, and then put in the versioning. Today we support 5.2.1 and the keys associated with it. There's a couple of other configuration steps. So this is where customers are going to say, like Andy talked about, like application, what networking IP space they need, etc. All that, and then click create. Once it's the click create is submitted, it takes 3 to 4 hours. This is like, if you think about it, on the contrast to that longer time frame in a data center that I'm talking about, takes like months to get this capacity first and then get the whole application deployed. So once we deploy it, I've already gone ahead and deployed an environment here. So as you can see here, the environment is deployed with 4 hosts. It's a 4 host minimum that forms a cluster for this particular application that I'm running. So you've got 4 ESXi hosts that's created on EC2 bare metal instances. So we're going first with i4i.metal EC2 instance. And we've got 4 EC2 instances. And then what EVS does in the backend is, within the customer's VPC, customers can give us what VPC, et cetera, that they want to deploy in. We take care of the underlying networking. It's pretty complicated. If you think about a data center, you've got to like build your routers and switches and take care of all that networking. We've taken care of all that for customers. So we build all this networking for customers. And then you can see these 3 tabs here. So if I'm a VMware admin, Jeff, you probably would relate to this. SDDC manager, NSX manager, and vSphere client. These are like what typical VMware admins would use. I would log into SDDC manager or NSX manager to configure my networking. We're not changing anything. We're keeping the experience consistent to what customers would do on premises, but they get the scale and flexibility of AWS cloud. So that's what you see here. I went ahead, I clicked, created an environment, and now I can log in and get the 4 hosts that you see, and I can scale it. We can scale up to 16 hosts today. And these are like really big machines. I4I are very storage intensive machines. So as customers think about running like databases or like different kinds of storage intensive workloads, they can use it. I think the key thing here is just the amount of time it takes to deploy this compared to an on-premises. The second is, now customers don't, like, as they go through this migration journey, they don't have to like really take care of, hey, I have to re-IP all of this. Like Andy and I just came back from Vegas. Like we were there for work. We talked to customers. And one of the main things that customers have told us is, I really don't like, it's not easy changing this application to completely serverless. Like I really want to keep my VMware infrastructure, but give me the ability to quickly launch it and scale as I go to take the advantage of cloud. So that's what we're doing here. We're giving customers the ability to deploy this environment and then get everything set up, so we take care of it, and then they can just focus on running their applications.
Yeah, Andy and Arthi, do you have an idea how many hours of my life was spent in a vSphere client, and how that like abruptly stopped about 5 years ago when I came to work at AWS? Now I'm like having like flashbacks. So Andy, I wanted to ask, I know you're an NSX guru. Some of those advanced features like NSX and the software-defined storage, like some of those things are even more complex than setting up hosts and everything at vSphere and vCenter. I assume that stuff comes over as well. I see the NSX manager in there as well.
Yeah, so NSX is VMware's kind of virtualized networking technology that they built in. So I mentioned earlier how they did compute virtualization 25 years ago. They also do network virtualization and storage virtualization. So yeah, you're absolutely right. Like kind of the cool thing here is we focused on being able to go from 0 to a functional environment in just a few hours. And I'm sure, Jeff, you've been there. I know I've been there, where you have just a bunch of boxes sitting in a data center. You have to rack and stack cable, but then you have to go like configure the networking stuff first, and then deploy the servers, and then deploy the ESXi operating system. Like it's just a layered approach that you have to run through. It takes a lot of time before you can ever get to running an actual virtual machine. And so kind of the experience Arthi was demonstrating here is you click a few buttons, give us the information, and hit go. 3 hours later, you have a fully functional VMware environment, which is great. But then the neat thing is, how many times have you kind of been like in a situation where you're running out of capacity? Like, oh gosh, like we need to add more machines, or add more virtual machines, but we're out of the underlying capacity.
Oh, yeah.
And in this case, you can click a button and add a new host into an environment in like 30 minutes, as opposed to going through another procurement process and all that. So you get the elasticity of the cloud while still using kind of the legacy virtualization platform.
You were talking about to build on this, moving fast and deploying fast. Like we see a lot of customers that all of a sudden a contract is over where their data center is. Maybe they don't own it and they're coming off of lease or something and they need to move. hardware support. Maybe that's coming out of support and they need to move. But the other thing is, I love that you talked about scaling. There are just times when like we need another whole ESX cluster, and that, even if you're planning for it, has to start sometimes 6 months ahead of time. So say you're using a blade infrastructure and you have to get a whole new set of racks and you have to get the data center guys to find space for it. And you mentioned a bunch of servers sitting on a pallet somewhere. Sometimes, I'm not going to name names of any companies, but sometimes a company will have multiple docks and you don't know which dock it was delivered at, and you have to find that stuff. That all takes a lot of time, even if you're planning for it. So it's really cool to see this. Hey, we need more infrastructure. 3 hours, we have it. And it's very familiar. You're going to open up those same links, and after it's deployed, you're going to manage it the same way you've been doing for the last 20 years.
Yeah, that's absolutely right. Like if somebody is running VMware in an on-premises data center today, like if you have an on-premises data center running VMware and you are looking to move to the cloud, one of the fastest ways you can do that, if speed really matters, then you can effectively just lift and shift that VMware environment into the cloud. Now, if you have a longer time period, like you can certainly modernize those applications and move them over and go that way. That's probably a better way to go if you have the time to do it. But if you were in a time crunch, if like your boss is breathing down your neck, you're like, hey, we got to get this thing done in 3-4 weeks. Like this is really just a fast path to be able to lift and shift those workloads over.
So Arthi, I've got a question then. We've talked a lot about the networking environment, the easy learning curve to get the environment up and running, the compute. But I know one of the huge benefits of the launch of Amazon EVS is all about the integration with third-party storage. Can you tell me a little bit about the storage story here? Because I think it's
Yeah, absolutely. So the instance itself, like i4i.metal, comes with storage, but we know customers, and he talked about like some of our on-prem customers have been using NetApp storage, for example. So what we've done as part of the launch is partnered with our Amazon FSx for ONTAP NetApp team. So what customers could typically do is once the cluster is up and running, they could go into FSxN, create a file system, and then go attach it either using NFS protocol or iSCSI protocol, and then get that additional storage. Where it helps is if I'm a customer and I want more storage, I really don't need compute. Like I don't have to go add another i4i.metal. I could just create a file system and then use it as my secondary data store. We're also partnering with other ISVs today, Pure Storage, for example. There's other ISVs in the market. So if customers are using these software vendors on premises, we want to make sure they get that consistent experience even while coming to AWS.
Yeah. So what I wanted to know, we talk about keeping, your skills and, your VMware admins who have been doing their thing forever and they know exactly, what to do. Once this is set up, we see that those skills can be used to manage your environment. There has to be something like, do you guys envision the VMware admins picking up this portion of the AWS management console to handle these deployments? Do you see like an enterprise cloud team kind of doing this first part and then handing it off? Can you talk a little bit about that, or what does a VMware person need to learn to kind of work with this?
Go ahead, Arthi.
Yeah, sure. Yeah, Jeff, like even when we talked to customers initially, that was our first ask. It's like, hey, how much cloud skills do I need to go get this environment launched? And that's why we've taken a lot of that abstraction. If you see, the whole environment can be deployed using a CloudFormation template. They really don't have to like go through all the 5 steps. They could create a JSON file. So we want to keep it as simple for the VMware admins that just like want to keep their VMware skill set. But we're also seeing, honestly, like people want to learn the cloud because they want to evolve with the technology. And so what we're also seeing is we envision most VMware admins will be able to go through this deployment, but for proper planning, I think as best practices, we tell them, hey, sit down with your cloud team to understand your IP space planning in the cloud. It might be different from like your on-premises, for example.
Yeah, well, I guess, Andy, you could probably relate to this. If back in the day you set up NSX by hand, and if you could figure that out, it sounds like you'll have no problems figuring out how to deploy and use EVS.
Yeah, we've tried to keep it as simple as possible. And like you said, this is a great opportunity for those who are coming from a VMware background to get a chance to learn the cloud. So you can actually deploy VMware, have it up and running in the cloud. And like we've seen customers do some cool things, like they're migrating their on-prem environment into EVS, but then they'll take their database, move their database into RDS, which is our relational database service. And that lets them get experience with, hey, I'm just going to move my database over into RDS, but I'm going to keep all my applications over in VMware. And as they get more comfortable and they get a chance to experiment and learn more with other AWS services, they can move those applications over. But you're not forced to. Ultimately, you can kind of pick the best place. You know, we're all about giving customers choice. If VMware is the right place for you to run that workload, go for it. Like keep it there and run it there. If you want to experiment or run other applications and different AWS services, you ultimately have that option available too.
And in the spirit of experimentation and deployment, a quick search suggests that while you have the AWS console at your leisure, this is also supported. There's a resource and cloud formation. The CLI still supports. So the same tenets that we use to design services, environments, and networking and compute primitives seems to absolutely apply here as well.
Yep, that's absolutely right. We build everything API first. Like before we ever like build the console experience, we start with the API. So it's very much something you can do, you know, from an API perspective without even needing the console.
Yeah, so I guess we're kind of getting towards the end of our allotted time. What would you say if folks see this and are interested? And really quick, I love that you said, you know, we always talk about choice for our customers. And it's not that we say migrate every single thing. AWS wants to provide the tools so that customers can make the right decision based on what their requirements are. And for some customers, it's going to make the most sense to use EVS. For some customers, it might make sense to do a full migration when they have the time or whatever. But in efforts to, you know, if someone's seeing this and watching this and say, oh, I might be interested in this, what would you recommend, you know, to read about more or to do a little more research or to, you know, possibly even play with this? I'll leave it to you, Andy. What would you suggest?
Yeah, good question. So all the documentation for EVS is out there and available. We're working on getting more and more content out. The service is generally available. So if you would actually like to go and do testing, this is another area. Like if you in the past, if you wanted to deploy a VMware environment, you had to buy hardware and commit to it for years. At this point, you can go deploy infrastructure. You could do a proof of concept test for a couple of weeks and then shut it all off. You're not committed to that. So if you have a situation where you need to migrate to the cloud and you need to go quickly and you're running VMware on-prem, this would be something I would just encourage folks to take a look at. If you do need to run VMware, we really want to be the best place in the world for you to run that VMware environment.
On behalf of the entire AWS OnAir team, congratulations on the launch. We're so excited to see what customers build on Amazon Elastic VMware Service. Welcome to come back anytime. And thanks so much for joining us.
Yeah, thank y'all. Appreciate it.
Thank you.
Thanks. Pretty exciting, Robbie. I love giving more choices to the customer. Like, you don't have to do this, but if you need to, if this makes sense for you, we have a tool to help you do exactly that. And we have a bunch of other tools to help you do with your other decisions too. And so there's a lot of different scenarios in IT, and it's just nice to provide the customers with that choice.
Absolutely. And we have so much more coming up throughout the show. And I'd be remiss if I didn't announce one of our favorite parts of the show. We talk about, we want to empower you to get hands-on, and there's no better way to do so than with AWS credits. So we have a simple challenge like normal. If you take our survey with your AWS Builder ID, for the first 30 builders who respond, you get $20 in AWS credits. And what I've been planning to do for quite a while is share fun projects that I use that I build with. That's often $1 or less. So maybe I'll share later. But we want to hear feedback from you. Typically, we always say our producer Nick reads the feedback. Well, this week he's out. So this is if you were looking to provide negative feedback per usual on Nick, he's not here to read. So save it until next episode. We have our best producer in Debbie. So we're only looking for positive feedback here today. The negative feedback, when Nick comes back, we of course welcome.
Well, that's great. So part of the feedback I'm giving right now is that we have this like marathon episode. Normally it's only an hour, but this time it looks like last week it was a 2-hour episode, or the last episode, and now it's another 2-hour episode. I have to pace myself. And you know, Robbie, you have a bunch of energy. I don't know. I need to I don't
Buckle
know.
up, Jeff. We're not even halfway done. The party continues.
I'm getting tired, man. Yeah. What's next, Robbie? tell us what's going on.
So typically, from what I remember, we typically do maybe 2 segments, and then we bring on our partner segment by our friends from NVIDIA. This time you said, you know what, let's bring NVIDIA right out front and center, because we have a really, we collaborate with NVIDIA all the time across various different business units, product integrations, et cetera, et cetera. But this segment is very close to home because I've had a chance to work with our AWS startups team and NVIDIA Inception, which is their startups organization, and trying to find some of the coolest startups we can find to impact industry. So not just providing them with enablement and credits and what they need to really get their startup off the ground, but how do we help sustain their business by matching them and matchmaking them rather to some of our largest customers. And so we created this program called the Telco AI Fellowship that's been super, super exciting. And we wanted to feature one of those companies who've done incredible work on both AWS and NVIDIA. And this particular customer in personal AI is thinking about AI assistants. Imagine if you had like a sandwich shop, Jeff, and you got to focus on making those sandwiches. You don't have time to pick up the phones, but you want that AI assistant to know everything about your menu, hours, and sound like a real human, to be able to do most of the tasks using natural language and in a very natural way. And that's exactly what we're going to see here today.
Cool. I'm excited. Let's get to this next segment then.
Suman, welcome to the show. Welcome to Personal AI on AWS OnAir.
Robbie, good to see you. And Jeff, nice meeting you.
Nice meeting you too.
Let's start with telling the audience a little bit more about what you do, how you do it, and your role at Personal AI.
I'm the co-founder and CEO of Personal AI. What we do is we create highly programmable small language models that are really good at precision and scale. Currently, we are working with NVIDIA on enabling all the telecommunications network to basically run AI on the network, focused on small business owners.
And so I did a quick search. There's about 30 million, if not more, small businesses in the United States that can easily benefit from this type of technology, who need a rapid digital transformation. And we see a tremendous role. Jeff, don't you think that generative AI can play? I mean, this is so powerful.
Yeah, and well, I know some of the small business folks that I work with. They don't have an IT team. The owner is the one who's making coffee, is the one sweeping the floor. They don't have a rack of servers in the storeroom. It's a real janitor's closet. So, but they could absolutely benefit from this stuff.
Yeah, Jeff. Earlier Robbie was saying you're making the burger, right? Think about majority of the small business owners in the United States specifically run their business on talk and text, right? Think about the auto repair shop. Make a phone call. Well, as a customer, you want to get your car fixed, however, the owner, the hands are greasy because they are fixing a car. So now imagine a AI receptionist that has the products and services and the knowledge and the relationships of that particular small business owner that is available to you to handle the inquiries, to take the orders, to even tell you the status of what's going on without having to install additional network or software or anything of that sort, because it's happening on their existing phone numbers. And that's our work with telecommunication providers.
Yeah. So can you tell us a little bit about kind of how you foresee that all makes sense and almost sort of close to edge type, the compute running in the telco data centers, et cetera, et cetera. Can you tell me more about walk me through that car shop owner, how would that work? I mean, you've set the stage, what would their onboarding process be like?
Well, on the onboarding process, a small business owner would go to their existing telco provider, call it any of the large 3 or 4 in the United States. And they would go through a series of simple steps of entering their website, for example, to basically bootstrap their AI receptionist that is then integrated or enabled on their existing AI line. So you're talking about, I have a AI phone number where my customers call. Now I'm going to upgrade that phone number to an AI line where the receptionist is. Now, you're talking a lot about edge, right, Jeff? If you think about what's happening when you pick up that phone and make a phone call, right? It's going to the towers, and the tower's going to, route the signal to you. Now we are adding this like AI as a proxy to pick up the phone call on your behalf. Well, the reason the edge infrastructure is really important is these are closest to the network. So when you have a personal AI cluster and NVIDIA GPUs, running AWS, that is closer to the network, you are eliminating the latency that is associated with providing a good experience and performance, as well as you are creating larger throughput to basically fulfill all the capacity that is available at this edge infrastructure. So edge infrastructure does play a critical role in this overall experience, and thanks to AWS distributed architecture.
And I know I want to see this demo, because this demo tells the whole story. And while you're pulling that up, Suman, I know we've got AWS Global Infrastructure. You can work with regions. You can work with local zones. You can work with Riva. You can work with accelerated compute on EC2. But let's see how this works. Tell me the scenario here.
Okay, so what I'm gonna do is the scenario. Imagine a small business owner that is a bakery shop, or a lawnmower, or a landscaper, for example. The bootstrapping process will take less than 15 seconds, right? Compare that to the industry Salesforce Agentforce of like 15 minutes. And then within 15 seconds, you will be able to make a phone call and then start picking up, client responses. So Robbie, I mentioned to you, I'm gonna play a video, and this will be 2 phone calls, right? One phone call would be Christy making a call to a lawnmower, and she will hang up. She will tell the scenario, and then she will call again. Because one of the key things is also, how do you maintain this relationship for the small business owner, with the end clients? So let me go ahead and play it. Give me a thumbs up when the audio comes through well.
Hi there. My name is Christy, and I'm calling because my lawn needs some help. I'm wondering what services you offer.
I'd be happy to help you, Christy. We offer commercial landscape maintenance services in San Diego County, including artificial turf installation, concrete work, hardscaping pavers, irrigation, landscape construction, outdoor living spaces, planting and mulching, and retaining walls. Can you tell me a bit more about what you are looking for?
Yeah, we moved into this house really recently, and the grass is really patchy. There's a bunch of weeds, and there's an overgrown shrub situation, and the flower beds are pretty much non-existent. We'd like to get it looking nice without breaking the bank.
I'd be happy to help you with your lawn renovation. Considering your patchy grass, weeds, overgrown shrubs, and non-existent flower beds, we could start with a lawn cleanup and weed removal, followed by planting some new flowers and shrubs. What's your approximate budget for this project?
I'm not too sure. How much would something like this cost?
For a lawn renovation like yours, costs can vary depending on the size of your lawn and the extent of the work needed. Generally, a lawn cleanup and weed removal can start around $500 to $1,000. And planting new flowers and shrubs can add another $1,000, $3,000.
Do you offer any kind of maintenance plans after the initial work?
We offer customized maintenance plans to ensure your lawn continues to look its best after the initial renovation. These plans can include regular lawn mowing, trimming, and fertilization, as well as seasonal planting and irrigation management. I'll make sure to include maintenance plans.
I'm sorry, I forgot to ask. Do you offer any discounts if I bundle services?
We do offer discounts for bundling services. If you combine the initial lawn renovation with a maintenance plan, we can provide a discounted rate. I can check on the specific details, but typically we offer a 5-10% discount for bundled services. Would you like me to look into this further for your specific situation?
Yeah, that would be great.
I'll send the details of the bundled services and the discounted rate to your email for your review.
Awesome. My email is christy@personal.ai.
I'll send the details of the bundled services and the discounted rate to Christy at Personal. For your review.
Awesome. Thank you so much.
Man, Christy.
Hello, I'm so glad you called. How can I assist you today?
The second part of the demo is also fun, Robbie, because the AI remembers who Christy is.
Wow.
Right, and then moves on with the conversation. So it maintains the relationship. That's kind of cool.
I was going to say, I mean, Christy goes from having a conversation that otherwise would have been a week's worth of emails, human intervention, to just having a seamless few-minute call. I mean, it's so compelling.
I think
Jeff,
from a small business owner's perspective, there are otherwise would need to staff like $4,000 or $5,000 per month staff member to be able to handle these things, because these are small businesses and it cuts the bottom line, right? That's the value that it is adding.
Yeah, and one of the things I noticed is, I think one of our listeners was mentioning that the lag might be a negative experience, but think about all of the information the bot was kind of replying with. She was kind of doing like a quote on the fly and kind of taking their questions and answering the questions with quotes and everything. There was a little bit of a lag, but I'm thinking about the time saved, like, oh, let me look this up. What are our prices for this and everything? And the bot knew that right off the bat. So
yeah, interesting on the
there, but I could see the time savings there as well.
Yeah. And the lag is right now on that demo, it was 1.5 seconds, which is one of the high performing performance like on the network, right? This is going through the cell towers and not just like a audio OTT call. Yeah.
So just to close out here, I mean, I definitely encourage everyone to give Personal AI here a try. But what would you recommend both to developers, to enterprises, to small businesses to get started with the minute we have left here?
The best is personal.ai. Very easy. Personal AI. You search in Google, it will be the top hit. There is a request demo form, and then we'll show you the insights of what's going on with the platform.
Awesome. On behalf of the entire AWS OnAir team, Suman, we hope to have you back again. Congratulations on the really compelling collaboration between AWS and NVIDIA. We can't wait to see how you transform and disrupt enterprises and small businesses alike. Congratulations, and thanks for joining us.
Thanks, Robbie and Jeff. This is great. Good luck.
Thanks, Suman. Really neat. It's one thing, like with all of the generative AI stuff coming, like it just seems like you hear really cool ideas every week. And that was just neat to like have it at the telco edge and basically have like a small business subscribe to that service with their business number or something like that. So that's really cool.
Absolutely. But we got to march right along to our next segment here. So I'll keep it brief, folks. If you think about the journey we've taken in terms of segments that our service teams here at AWS have led, we started with the world of migration, starting to think about how we can modernize the world of virtual machines on AWS. But we recognize that a lot of customers are already running containers. And for those who haven't worked with containers, lightweight packages of software that contain all those necessary elements to run applications. And we know that just like virtual machines, there's a bunch of ways to run containers on AWS, whether you're a fan of Kubernetes and Amazon EKS, Fargate, AppRunner, the list goes on, but we have a special place in our heart for Amazon Elastic Container Service and ECS. And as you think about rapidly making deployments, you have to think about ways to manage those deployments in a deterministic way, how you can manage changes more frequently. And there's no one better to bring out to help us think about how you can manage these deployments than our services team covering the recent launch of blue-green deployments on Amazon ECS. Let's bring them on.
I told you, I'm excited about this.
Jay,
hello.
Welcome to the show.
Happy to be here.
Yeah, Jay and Vidnov, can you guys just introduce yourself and tell our viewers what you do and what we're here to talk about?
Sure, I can get us started. Hi, my name is Vibhav. I'm a product manager with Amazon ECS and AWS Fargate. Look at all things ECS and Fargate here at AWS.
Yeah. And my name is Jay Russo. I am software dev manager at AWS, specifically working on ECS.
Jay, really quick, what's your favorite color, blue or green?
I like blue, as you can see in my walls. So yes, I like blue.
Well, it's funny. Blue-green is deployments, something that I think a lot of people learn maybe when they're studying for AWS certification tests, and especially if you haven't been a developer before and you're picking up that terminology. Can you guys explain what blue-green deployments are?
I can take a stab at it. So very simply, a blue-green deployment is a process of rolling out software where you create a new environment, which is an identical replica of an existing environment, just running the new copy of software. You validate whether the new software is running in the way you expect it to, so run some tests against it, but without sending any amount of production traffic. Once you've done all of the validation that you needed to, that's when you cut over all of the production traffic over to the new version of software. Keep around the old version for a while so that in case you detect something has gone horribly wrong, you can go back within a matter of moments, reduce the blast radius of an outage if there was going to be one. That's a blue-green deployment in a nutshell.
And I think as Jeff mentioned, extensively documented in the literature and the AWS certification literature, of course, ECS, of course, has been around for more than 10 years. So we've been building on best practices, on best practices, on best practices. And it's no surprise that you can manage a blue-green deployment today on Amazon ECS through the likes of a code deploy. So what were the customer pain points that were like, no, we need this natively? What happened?
For sure, yeah, and as you rightfully called out, Robbie, ECS has supported blue-green deployments via code deploy for several years now, and a lot of customers love that, love the flexibility that offers. However, over time, what we've realized is customers choose ECS for its simplicity, for the fact that there's very limited resource management that you need to care about. Like in ECS, a cluster is just a logical entity. You never interact with a cluster per se. All you're dealing with is your application for the most part, and with code deploy, while we retained some of that simplicity, it still added some amount of additional overhead in terms of setting up your application, in terms of creating additional resources that you otherwise wouldn't have to. Customers really care about deployments for their containerized applications, right? Like the reason why I chose to containerize in the first place is to go quick, to have, and in order to go quick, I want to have safety, and it's really fundamental, really intrinsic to containerization, how quickly, how safely I can deploy. And in order to make that, give customers that safety guarantee out of the box without needing to reason too much about how I'm needing to configure a bunch of extraneous resources or additional configuration parameters, we decided to build all of the best practices for deployments inside of ECS itself, so that when you're creating your application in ECS, you can just say that, hey, I want to use a blue-green deployment strategy, and have the ability to safely roll back very, very quickly, have the ability to test your application against non-production traffic before you send any production traffic to it.
Yeah, Robbie, we're seeing this motif here. Again, we'll bring up choice for our customers. Are you really into Kubernetes? Then you can use EKS. If you want to simple it down, or you just need containers, maybe ECS is the right way. And now it was, all right, here's some best practices for blue-green. Here's some extra steps to do it. You guys listen to customer feedback, and now you're kind of integrating it into that. So I love that ability to fail back, I guess, or to switch over. Can you talk a little bit about that? How quick is that? How easy or how hard that is with this new feature of ECS?
So lots of ways to do that failover, right? So like that failover can happen, and I'll focus really on the scenario where you've shifted production traffic, and that's the point where, like, oh no, something has gone horribly wrong, I need to go back. Normally, if you weren't using a blue-green deployment, what that would mean is restarting a bunch of containers, getting those into a healthy state. Depending on the nature of your application, that can take minutes for those replicas to start running and become healthy and be ready to take traffic from your from your end users. And now, instead of that, with a blue-green deployment, all of those replicas are already running. All that is happening when you choose to roll back is a simple cutover of traffic. So when you're using a load balancer for managing traffic, that usually means seconds, for single double-digit seconds for rolling back to the old version rather than minutes as it would normally take. The process is super simple. Like you can literally go to the console, click on a button, and the rollback will happen. Or you can use the API, or you can use CloudFormation, whatever interface that you want to use. It's a simple single action that makes that happen. And further, you can automate that too. Like, so let's say you want to monitor, hey, if there's a spike in HTTP 500s, automatically roll this back. You can set up that alarm, and ECS will monitor that alarm for you. And in case that alarm goes off, we will immediately roll back as well. So lots of ways to add safety for your deployment.
Yeah. Robbie, that sounds a little bit like event-driven architecture. Maybe we'll talk about that a little bit later.
We shall see, but I think seeing this automation with a live demo is absolutely key. So if we can bring up that live demo, and let's just define our terms here quickly. For those experiencing ECS for the first time, cluster, tasks, services, go.
Sure. So I'm going to show you an amazing demo. So cluster is basically, it's really a synthetic grouping of tasks and compute. There really isn't anything special about a cluster per se. It's just a grouping that we use for our tasks and ultimately our services. A task is one or multiple containers that are running on the compute, and services are just managed tasks. So if you want to have a task that is running in perpetuity and tell ECS to make sure that that stays healthy, that is what you want. You want a service.
Awesome. So let's build up the scenario here. So if I have an application, a task, a service, it's some web application that's simple or something like that. Why am I? What am I deploying? What kind of change am I making? And set up the blue-green deployment here for us.
Sure. So why don't I walk you through what we have here? So I have a service that's running, desired count of 3. That's kind of kind of minimum best practice that we think is good to start out with. So we have 3 tasks running. ECS keeps those tasks healthy. So if for whatever reason I am not a good developer and the task dies, ECS will actually start a new one on my behalf. I don't have to do anything. But let's say I want to actually mutate this service and actually do an update to it. So let's take a look at the service running right now. So this is the actual service. So this is the task that's running behind a load balancer. We have 3 tasks. So you refresh this, you're hitting multiple tasks on multiple compute. This right here is actually the production traffic, and I actually have another listener on the load balancer that is actually our test traffic. Now, right now they look exactly the same. In fact, they are exactly the same. They're pointing to the same exact tasks, running on the same exact compute. They are identical. But what we want to do is we actually want to update this service and go to a new version. So I'm going to walk you through what that means here right now. So I will say update service. And right now I'm on version 6. Let's say I want to go to version 7. So I'll go from 6 to 7, and I will keep my desired tasks the same.
And the task definition here, Jay, so that's something you already did, like a manifest that's basically like, hey, I've actually changed the container image that's pointing to this Elastic container registry details, et cetera, et cetera, et cetera.
Correct. Yeah, there's really nothing super secret in my task definition. It's just HTTPD, where I'm just injecting some customization. But yes, it's just a definition of what the task should look like, which containers, shape and size of the compute, and ultimately that's what's driving what will launch on the compute itself. So if we go down,
Jay, what's interesting, the version you picked looks very familiar to picking versions of a Lambda function in your code there, and how you can sort of do the same thing with Lambda. But so that's interesting.
Yeah. So when you mutate a task definition, you will actually automatically create a new version.
Cool.
So I mutated this a few times, up to 7 times, and now we're going to go from 6 to 7. So you can always go back to a previous version just by selecting the older task definition and deploying it. But in this case, we're actually going to deploy the new version, look at it, test it, and then ultimately roll it back.
Yep. So, and to this point, everything prior to what you just showed us on the screen was what you can do with Amazon ECS today and how you manage deployments.
Correct. This is where we get into the new fun stuff. So what we're looking at here is the new deployment strategy. So we have blue, green. So as Vibhav mentioned, we have a blue and a green environment. Fundamentally, it's just a new version running at the same scale that we will shift traffic and then ultimately either progress it or roll it back. We do have this option of customized bake time now, so we can put in a bake time. Right now I had it at 0, but let's say I'll put it at 15 minutes. What that will do is, at the last stage of the deployment, it'll essentially wait around for 15 minutes just in case. Maybe I have some alarms or some manual testing that I want to do, where I want to give myself a 15-minute grace period. So we can set that 15-minute bake time. Now what we're going to look at is this lifecycle hooks. So lifecycle hooks are really where the magic can happen. What we have is the ability to call one or multiple Lambda functions during different phases of the deployment. So for this demo, I'm just going to do a single Lambda function that's actually going to be during the post-test traffic shift. So I look at the lifecycle stages. We have multiple lifecycle stages. We have reconcile service, pre-scale up, post-scale up. You can read the rest. Pre is, as you would expect, before something happens. So before we scale up. Post is after something happens. So after we scale up, we will do something. For this demo, the thing that makes the most sense is actually the post-test traffic shift. So I'm going to select the post-test traffic shift. And what that will mean is I'm going to scale up my compute. I'm going to launch all of those tasks. I'm going to shift my test traffic. So if we were to go back to this demo here, this application will shift to the new version, but the production one will stay the same. And then some tests will likely run. Ultimately, they will fail or progress, and then the deployment will complete. In order to actually do this, I have to select a Lambda function and then a role. I just have a simple role that will invoke that. So now we scroll
It sounds
down.
like this Lambda function is going to check the test results to see that something was a successful or failure, just like you said,
Yeah.
and then maybe possibly do a shift over or whatnot if something bad happened.
Yeah, so this test, Lambda, is actually very simple. All it's actually doing is looking in a S3 bucket and looking for a success or failure text file. And if it doesn't find either of those, it just assumes it's in progress.
And you're simulating a test right here. That's why it's so simple, just to get the point across. So that's understood.
Yeah. But honestly, that is a potential use case. So you could have a test that gets triggered that runs somewhere else, does something, gathers those results, and drops the results of the test in the bucket. So it is a simulated test, but it's a valid use case.
Yep. And it's completely DIY. So like you can decide whatever tests you want.
Exactly.
Yeah. Okay, so now let's look at the load balancing. So load balancing, previously you really only needed one listener, one target group. Now we have the ability to actually shift between target groups. So for this demo, I have a single load balancer that is my amazing ECS load balancer. I have a listener for production, which is listening on port 80. And then I also have a test listener. So that was the one that's listening on port 8080. And I have two target groups. So this is where the blue and the green environment are going to live. So these two are actually equal in terms of what they are doing. We actually just move blue and green between the two. They don't mean anything semantically. It's not like the alternate is any less of a target group. They're just two target groups that we use. And that's really all you need to actually do the blue-green deployment. So if I click update here, this is actually going to trigger the deployment. And then we refresh here, we can see here we're in the current deployment stage of pre-scale up. So what we will start to see is tasks will actually start getting requested and start running. So now we're in the scale up phase. And while we're waiting,
we can see the little bar graph changing color up there.
Yeah, so we've got 1 pending, 3 running. So this first one is actually how we stay consistent. So we launch a single task to make sure that we can get all of the digests for the rest of the tasks and make sure that all of the tasks running in the green version are identical. So that's why you see 1 and then multiple. So now we have 4 running. Now we will see 2 more being pending. Here we go.
And so presumably over time, we'll now visit a new URL associated with that load balancer, and suddenly that color might change.
Yes, so this is our test listener. So remember, we have our prod listener here, listen on port 80, and our test. So our test is running on 8080. So what we would expect is after the test traffic is shifted, those two will be different. So our prod would stay the same. Our test would actually be different. So if we look here, so now we have 6 running. Now we're at post scale up. We should now go into test traffic shift. Again, go into test traffic shift. And then we should go into post test traffic shift. That's what's actually going to be triggering my Lambda. But now if we do a refresh here, wait until go to post.
While we're waiting here, we only got about 1 minute left. So maybe we do this in reverse order. We want to see the change in page, but if you can tell us in parallel what folks can do to learn more about this launch, that would be awesome.
Probably the best place to go learn about the launch is to just go create a service in ECS and try this out. Like the feature is available across all AWS regions. Yes, we see success. The demo gods have smiled on us.
Yeah.
Perfect. Right in time, gentlemen. We've got to run, but we're so glad you had a chance to stop by AWS On Air, folks. Blue-green deployments native on ECS. Go check it out. Thanks so much for joining us.
Thanks for having us.
Robbie, like I was getting a little hot in here, but then all of a sudden the flames came up and the screen turned green. So that was good.
Always good when a demo goes right. And I don't know if you saw the bottom, the rotating carousel on the screen. This is our favorite segment. It marks about halfway in our 2-hour journey together. You're always probably wondering what's happened over the past few weeks, and you don't want to hear from us. You certainly don't want to hear from our producer Nick, who's on vacation. But you might want to hear from the man, the myth, the legend, Jeff Barr. So let's bring him right up.
The Eagle has landed.
Jeff and Robbie, great to see you both today.
Happy Friday, Jeff. Thanks so much for joining us.
Sure. Always happy to be here. I missed doing these last couple of weeks during travel and our shift to our every other week schedule.
Does that mean you're going to have twice as much content this time?
You know, nobody asked, but I could conjure some up if we need to.
Why don't we start then with your 3 favorites over the past few weeks?
Sure.
Here,
Okay. All right. Well, happy to be here as always. If you don't know me, I am Jeff Barr coming to you today from Seattle. Earlier this month, I hit my 23-year mark at Amazon. And one of the favorite things I get to do every week is I go through our most recent launches and I pick just a couple that catch my eye.
Really quick, Jeff, what color is your badge now? What's 23 years? Is that
23? I still have silver.
Oh, so it matches your hair. So
it does, yeah. It actually does. And at 25, I will get gold.
Nice.
So that is my next big aspiration in my career.
Is the hair going to match it for that week? I think it should.
We could maybe do that.
Yeah. All right, cool. Sorry to interrupt, but congratulations. That's
gold would be awesome, actually. Okay, so the first awesome thing are the new R8i instances. And so this is the 8th generation of our memory optimized EC2 instances. And these are, of course, for your memory intensive workloads, your SQL databases, your in-memory caches, in-memory databases. These are built by powered by custom Intel Xeon processors. They're actually available only on AWS. They will do an all-core turbo up to 3.9 gigahertz. And in contrast to the previous generation, they have a 4.6 times larger L3 cache, which is one of the reasons why they're faster. If you're doing all the numbers, you get 15% better price performance, you get 20% higher net performance, and you get 2.5 times the memory throughput of the previous generation. So huge wins there. You can get them in 11 sizes, anywhere from 2 to a kind of like a mind-twisting 384 vCPUs. Kind of amazing numbers. And anywhere from 16 gigabytes up to 3 terabytes of memory. And in addition to that, you get two sizes of bare metal instances. But that's not all. There's even one more cool thing, is that in addition to the regular R8i, which give you full performance all the time, we have this interesting variant called the R8i Flex. So these are 5% less expensive, and they will give you full performance 95% of the time. So when you need that, when you have high memory workloads, but you say, well, most of the time we need full performance, but sometimes we don't, then I think the R8i Flex is a really, really cool option. And we will drop a link to that in the chat. There it went, just popped out right there.
Wow.
Okay, ready for another cool thing?
Let's do it. We covered compute. Now what? We're going to cover
Now let's go to databases. Okay, so there's a certain kind of launch I love. I call them the chocolate and the peanut butter launches, because I do love chocolate. I do love peanut butter. And we all know that those are two incredibly complementary flavors. So the chocolate today is Aurora DSQL, which is our fast serverless distributed SQL database. Gives our customers high availability across multiple regions. Super, super cool. And then the fault injection service, which we also call FIS. And this is cool, because I love this because it lets you break stuff in a really controlled manner. So the idea is you define experiments, and you say, I want this part of AWS to be either somewhat unreliable or fully broken or slow to respond. And this way you can define these different kind of experiments. You can run tests. And then when you build some kind of complex architecture, you can observe and measure and be really kind of happy and confident that if some part of your infrastructure or your application starts to fail, that you kind of know what happens, what parts get slow, what parts break. And then in most cases, we say you should do this in your staging environment. When you're super experienced and super bold, you can actually start to do it in production. Like we've had customers in the past who, when they were in physical data centers, they would like literally go into the data center and start pulling out network cables and power cables, and just to make sure everything worked as expected, which is for the bold and the confident and the experienced. Okay, so we've got both of those. But now what we've done, we've put the chocolate and the peanut butter together. And so you can now, when you're using Aurora DSQL as part of your application, you can simulate a connection failure from your application to your Aurora DSQL cluster. And the neat thing with FIS is that you set this up as part of an experiment, and you can control some cool stuff. Like you can say, I'd like it to simulate the disruption for this amount of time, and you know, minutes, seconds, hours, if you'd like. And you can also do a partial or a full failure. So you might say, what happens if 1, 5, 10% of my connections fail? Does that affect my application? Do I notice it? Do I properly get notified? Are there the right failovers and mitigations and so forth in place? And so that I love the idea of FIS because of the fact that it can give you confidence in your application, because we've talked about, we've published all kinds of documentation, and we've built into AWS many different pieces and elements and guidelines and rules that are all about, here's how to make a resilient application. And you can engineer all of that into your app, and that's super awesome. But you never actually know what's going to happen until you try it out, and especially when you've got backoffs and retries, and you've got services that inherently say, well, okay, if this part doesn't work, I'll go to plan B and I'll do this and I'll retry. You've got client libraries, you've got mobile apps retrying. Wonderful theory. You can be 1,000 times more confident once you actually try all this stuff out and break it.
Yeah, and some of these things you can't, all you can do manually is like shut down a database. And so you can simulate a total failure. But with FIS, there's so many options to do, like increase latency at a random time and kind of do things that you can't manually do, and come up with that the whole continuous resilience is really catching on with a lot of customers. Yeah. And glad to see that we have a tool to help with that. And DSQL is getting, as popular as it is now. So it's great that they're integrating. Exactly. If I was actually building and running some big complicated AWS application, which I aspire to, if I was like took a different fork in the road in my life and my career, I would for sure be using this all the time. And
I would just want to be increasingly devious and probably even give my developers incentives to say, okay, let's dream up the failure of the week and let's try it out and see what happens and make sure that we're walking away very confident that we have thought about all this. And back in the early days of AWS, we actually used to run these events annually or the early days of Amazon, these things called game days. And the game day was often run sometime in the third quarter before the holiday season, and with lots of planning and preparation and monitoring and everybody alerted ahead of time. It's like today is the day we're going to start pulling plugs and breaking stuff and making sure that we're totally resilient for the holiday season. And you can think of FIS as like a couple generations past that to say it's now as automated as possible. And so I'm pretty psyched about that.
Really exciting.
Time for one more cool thing?
We got 1 more minute.
1 more minute. Okay, so this is cool and simple and helpful. You can now assign a color to each of your AWS accounts. And then you see that color in the console when you log in. You can choose from red, orange, yellow, green, teal, both light and dark blue, purple and pink. And then when you log in, there's a little strip across the top of the console that just gives you a nice little clue in to maybe like the status of the account. So maybe you're going to use red for production accounts and yellow for test ones and green for dev and I don't know, purple for personal accounts. But the idea is that just a little clue that maybe most of your accounts are green ones, just a few are red, that you see that little tiny strip there. You're like, okay, I need to think differently as I'm working on that particular account through the console.
You know, Jeff, can I make a suggestion? Can we do that for what region you're connected to? Because that's what always throws me off.
Ooh.
Like, oh, I'm in Ohio. Like, oh,
interesting. You know, no matter what feature we invent, there's always a new way to make it even better.
Yeah, but this is really cool.
So, what you'd want a different color per region per account as well?
Well, based off my past experience, I've always messed up by spending time in one region when I thought I was in Ohio this whole time. Yeah. And, you know, all the bedrock models are different or not even there. And I'm wondering what's wrong. But then a half hour later, I realize, oh, I'm in the wrong region. If I could,
or you panic and say, where did all my buckets go? Or where's my instance?
Yeah.
I've never, ever done that. Not even once. Not even once.
Oh,
well, I'm geared up to head off to, I'm heading off to Geneva and Sarajevo next week to speak to AWS developers. And if anybody in our audience happens to be in either of those two cities, hope to see you there. I'm heading to the AWS Gen AI Loft in London in October, I think, and then hopefully getting up to Vancouver as well. So always love to get out in the world and see and meet and chat with developers.
Well, we can't wait to hear how your travels go. You're, of course, welcome back anytime. Thanks for joining our news segment, and we can't wait to see what launches next.
Anytime. Good to see you both. Have a great show.
Thanks, Jeff. I think we got to go to Geneva and London. I think that's what I just heard. I don't know if that's what you heard. That's what I heard.
That was an invite for us.
I think so. We'll have to talk to our producers and see if we can make it happen. But for this next segment, first of all, shout out to our viewers in Canada. As a fellow Canadian here, super excited to have you. This is AWS. You do this better than anyone, Jeff, to reintroduce the show. You do. I can't take your thunder. This is what you do. Reintroduce what this show is.
Everyone. So, let's see. Let me think. So I was going to do the because we're in Canada, you know. All my friends in the Great White North and all of the Rush fans out there, welcome to AWS On Air. It is Friday, and we are entering the second half of our marathon episode where you will be learning all about new features, new services, cool demos, basically what's new with AWS. And we are your co-hosts. My name is Jeff Mershak. I'm a senior solutions architect. And with me is Robbie. Robbie, say hi.
Hey folks, Robbie Belson, solution architect. Happy to be alongside Jeff. We're about halfway into this marathon weekly AWS On Air episode where we recap the coolest launches and feature releases over the course of the past few weeks. But we're marching right ahead to our next segment. So again, zooming out, we started virtual machines. We went to containers. We covered from Jeff launches in Amazon EC2, new instance types, new integrations with Amazon Aurora. There's so much more, but as we keep moving ahead, I think we got to talk about serverless. And there's so many different services today that we offer in a serverless way, but we wanted to take a new database and make that serverless. And so again, I got to announce to the audience, I did not invent this. This is not my segment name. I don't necessarily even endorse this, but Jeff, would you like to serverless and chill?
I would. That sounds good right now, especially.
Let's bring out the guests.
Yeah.
I told you I'm excited about this.
I can't believe I just said that, but I did it for you, Vin. I did it for you. Welcome to
Thank you. We're gonna have a chill time here,
Vin, so tell all of our viewers kind of who you are, what you do, and what we're going to talk about.
Hey everybody, my name is Vin. I am a product manager on the DocumentDB team here in AWS, based out of Seattle. Super excited to be here.
So I think we got to start with what is a document database and what is the core architecture of what it looks like today in a pre-serverless world?
Yeah, so just really quickly, just catching everyone up on a document database. It is a database where it's based on JSON as the medium for transferring data. So if you are a web dev, you'll be really familiar with using JSON files. Pretty much, instead of thinking of tables, columns, and rows, you could use that as just inserting that JSON as a data or datum into your database.
Yeah, and that's something that, as I talk to folks and actually give interviews, we always talk about what's the difference between a SQL database and a NoSQL database. And DocumentDB often comes up as one of those non-SQL databases with non-rows and columns, et cetera, et cetera. So, so talk to us about the move to serverless. I mean, obviously there's reasons for serverless for all these, all of our different services, but talk to us why it's special with DocumentDB.
Yeah, I got a little bit of a diagram. If we could just bring up the screen, and I'm going to just swap my head over. Just a little bit of a picture here. So I'm going to walk you through just the traditional architecture, and then we'll transition to how this kind of gets into the serverless world. So if you look at our database today, prior to serverless, you have your database instances. So you have 3 replicas in your database. So in case anything goes wrong with one of the replicas, you have another one that steps into place. Now, let's talk a little bit about scaling for a moment. So if you want to scale your instances in your cluster, what you would typically do is remove one of these instances and add it back in. Now, that could be disruptive. Even though it is very minimally disruptive, it is still a bit of a restart you got to go do. So that can cause some challenges, and scaling also, it takes time, right? Even though we make it really easy in AWS to remove an instance and add an instance, it's still something that the user has to go do. So let's say you have Prime Day coming up or a sale coming up, and you want this to scale. It's an action that the user has to go do today to scale this up and down. Now, switching over to serverless, I have a little bit of an animation here. If I have my app, with more arrows kind of depicting more load, what serverless does is it scales this automatically up for the user. So you don't have to be taking the action and say, hey, I want to go from an R6G large to a XL, for example. This does it automatically. It brings in more memory, more CPU, and more networking for your application.
Let's see it. Bring me into the AWS console. I want to see how you would deploy this in a serverless way. What's different, what stays, and how I can see scaling.
Yeah, so I'm going to just start really quickly in the console. I'm going to jump right to the creation piece of it. So the only thing that changes, so typically when you create, you got to specify name, specify an engine version. But I want to zoom in and just focus on this instance creation piece, because we have this new radio dial here. So typically you would select an instance class. So you can see here, if you select a R5 16XL, you get a set amount of vCPUs and RAM. But instead, what I could do is specify serverless instead. Now, you could still choose the number of instances. You could go from 1 to 13, 1 to 15 here. And instead of specifying what the amount of RAM or CPU you would do, is you could specify something called DCU, which stands for DocumentDB capacity units. And what you could do is specify a higher limit to help you specify how much maximum resources you want. So this helps you prevent away from those runaway costs in case you have a dev workload, but all of a sudden you're blowing it up. So everything else is exactly the same. So by specifying a very wide range, you make it really easy to scale up and down.
So this is the serverless abstraction, folks. You still get to use the sort of most of the DocumentDB configuration you know and love, and maybe akin to an auto scaling group, we're basically configuring, you're saying like the replicas of saying, hey, here is a range of compute that I might need. Now you go figure it out.
Yeah. Yeah.
Then I might also say, is it kind of closer to the experience working with DynamoDB? Like with Dynamo, you kind of request a table and that's all you care about. It's not quite like that with this, but it's closer to that experience.
Yeah, it's a little closer. It's somewhere in between. I would say there's a class. I would say if you're familiar with Aurora Serverless V2, it's much closer to that model instead.
Cool.
Yeah.
Great.
All right, let's see this in action. So I have a fictional shoe store called DocDB Hyperkicks. I have a little website here, sale. Now, one thing that happens that's a very common use case for serverless is e-commerce, right? So let's say you have a sale coming up. You have to do a lot of things in your, in preparation for this. For example, we were just talking, Jeff, which was on a little earlier, Barr, and he was saying, there is a fault injection service. Well, with that, they used to just pull the plug, do a lot of game day testing, right? There's a lot of work that goes into preparing for, a scale up in load. So what we're going to do by using serverless, we're really going to simplify some of that. So I have a website. It only has a single shoe. I want to buy this DocumentDB serverless shoe. I'm going to click on buy now. And this is going to simulate buying 50 million shoes with a single click instead of us just sitting here all day. So I'm going to click on here. It's going to start executing. Now, what I'm going to go do is take a look at the performance monitoring of this database, which I just ran the load against. So shortly after, once I get the metrics in, I'm just going to zoom in to about 5 minutes. So you can see here, immediately, there's a little bit of a jump. What I'm measuring in this top counter is DCUs. So we just talked a little bit earlier about document capacity units. So you can see here, at this very current time, you see a spike. This is the load that's being applied to my database. I'm going to zoom out to 5 hours to look at a previous load just to show you a little bit of what we should be expecting. Now, here you can see that this little dotted line represents how many resources are applied to my database currently. And these little bar charts here shows how much load is being applied to my database. So you can see here, the dotted line is at 1. It has pretty much very little resources used. All of a sudden, when there's a load, you can see that the database says, oh, I need more resources. So it scales up immediately in reaction to the load that's being applied. Now, once it's done, it's going to scale back down. So if I'm not using it for this time, which you see that there's no load here depicting that, I'm not going to be paying for resources that I'm not using. So really good for variable workload use cases. So I'm going to go back to just 5 minutes. You can see here that currently it just spiked up the little dotted line. So the database has more resources being applied to it currently, and this is running in the background as we speak.
Awesome. So we've looked at deployment of the database. We've simulated additional load and how the database would dynamically scale in these capacity units, these DCUs, to accommodate that. What else can we see here?
Yeah, I would say there's so much to explore. But I mean, I know we're going to be short on time here. But one more thing, I just want to show you how easy it is to, if you are not using DocumentDB and you're creating a new cluster, you can go through this flow. But sticking on this, this one instance configuration diagram, if you want to convert an existing instance, you don't have to migrate any data at all. It's really easy. Just take it back and just chill a little bit, right? You just swap. You could just choose the instance class from your current instance class. Let's say you are currently in a T3 medium. You could just click a radio button to serverless and just convert back and forth. And if you find that this is not the right product for you, it's really easy to swap back and forth between a memory optimized instance class or a serverless instance class at any time.
So back and forth as well.
Yeah,
That's cool.
yeah.
So many products in IT over the years has been like, oh, we offer you to be able to switch, but once you switch, you can't go back. That is really refreshing that you can just change it whenever you need to. Again, Robbie,
Yes.
choice for our customers. I like it.
Yes.
Awesome. We only have another minute or two left. So if there's any key takeaways, Ben, maybe just to recap, where would folks go to get started with DocumentDB serverless? And maybe what are your top 3 takeaways for someone just joining the stream here about the exciting launch?
Yeah, so if you are using, so if you're not familiar with document databases in general, super useful tool to have in your back pocket. I know that many folks here are familiar with the relational databases. They may be familiar with Dynamo, but if you need a JSON database, NoSQL database, and you need really rich querying capabilities, check out DocumentDB. That's 1. 2, use serverless. Just take it easy. We have a long weekend coming up here in North America. Using serverless is just going to take off one more thing that you don't have to do in terms of scaling. And 2, this is not just a one-way stream. If you choose the product and if you're using this serverless and you find that it's not the right fit for your application, go back. There's really no pressure, or there's no one-way stream here. So those are my 3 takeaways.
Well, thank you for coming to Serverless and Chill with us here.
Yes.
The demo is super compelling, easy to use. What was it, the Z9000s? I'm gonna have to try to get myself a pair. So we've learned 2 things. Jeff and I are going to London, Geneva to hang out with Jeff Barr. We're gonna buy Z9000 shoes. And of course, we learned about so many different launches.
I know I'm going to reach out to Vin when my next favorite sneaker drops. We can write a little script to try to actually get it this time. So yeah, Vin, I'll be reaching. Yeah.
Sound good.
There you go. Thanks for joining us, Vin. We'll see you next time.
Bye.
All righty. We're like in the home stretch here, Jeff. We're hanging in there. Normally our episode is over, but we still are. We got plenty of content left here, don't we?
Yeah, we're going to be transitioning over to our friends from Repost to talk about some of the kind of related questions that they've seen in Q&A and kind of some best practices. But I don't want to steal their thunder, but we're going over to the Repost folks next.
Before we do that, though, if you want to get hands-on with DocumentDB serverless or ECS blue-green deployments or any of the launches we've covered so far, you're in for a treat. If you fill out our survey, $20 in AWS credits. First 50 folks. AWS Builder ID, we can't wait to see what you build. And if you have questions about what you might be building, there's no better place to go than AWS Repost. But don't take my word for it.
If you're loving this new marathon 2-hour show, that's the product of this survey.
Exactly. Exactly.
Thank you, everyone, for filling out that survey.
And let's turn it over to the Repost Live team.
Thank you, Jeff. Thank you, Robbie, for the warm lead-in and the nice plug for Repost. Hi, everybody. I'm Chris Thomas, a producer over at AWS Repost Live, joined by my good friend and colleague, Dalian.
Hey, folks. Good to be here. My name is Dalian Ayekpour. I'm a senior technical account manager in the travel and hospitality space, and I'm based out of Toledo, Ohio. We got an exciting episode for you. Obviously, if you've been tuned in, we've had a lot of launches, a lot of topics that we've been covering. And hey, as they mentioned, we're getting towards the home stretch, but we're not done yet. So if you aren't familiar with the Repost Live show, you can catch us Tuesdays from 2 to 3 p.m. Pacific time, where we go over some of your questions that you submit on our Repost platform, the community, as well as some of the articles and launches and expert guidance that we provide you over on Repost as well.
For sure. Thank you for that context, Dalian. And really, we should just get straight into Repost, since I know that we don't have a whole lot of time. It's already a really long show. Let's make sure that we're just staying as on top of things and as informative as possible. So if we head on over to Repost, there's a couple of things that I grabbed here. Of course, there's a ton of stuff that you can find on this site at any given time, but I wanted to grab things down that were related to the topics that we were talking about today. So we'll start off with blue-green deployments. I actually grabbed a question that's pretty recent. I know that the blue-green deployments specifically on ECS was something that launched fairly recently. So of course, there's a ton of questions, ton of blog posts, ton of articles that are featured here on Repost. But I grabbed down this one because this person's asking about some context around Lambda as it relates to the ECS blue-green deployments and some issues that they were running into about lifecycle hooks. Hopefully, with your experience, Dalian, you can walk them through the best way to resolve this.
Yeah, of course. And as we talked about earlier on the show, with the recent enhancements to blue-green deployments on ECS, definitely makes that process easier. So if you are in a pinch and you run into an issue and you want some new code or do some updates, make sure you start leveraging blue-green deployments so you can quickly switch back to an error-free environment, something that you're familiar with. So. But yeah, for this question in particular, it looks like the individual is having some issues with some lifecycle hooks. Things weren't working properly. They're getting failures. So obviously, with the recent launch announcement, they're using ECS. They can easily switch back to get some time to go into that, and so they can dig deeper. And particularly, just another great call out when using Lambda, making sure your Lambda execution time is set to a good enough threshold, right? So we were seeing here they were getting timed out because the default 30 seconds wasn't long enough for Lambda to run and execute in time. So make sure you're checking out for that. Just pro tip when setting up those Lambda functions.
That's all we got here. Nothing but pro tips all the way down. No, that's excellent. Adrienne, hopefully that this is helpful to you. We'll post a link to the recording here in the chat for you so that you can come back and take a look at it. But yeah, blue-green deployments. I know that in the past, rollback was a pretty common way for people to, I made a mistake, and then they got to go back and fix it. It's really great that this is now available on ECS to save you a whole lot of time where you can notice those and flip back to a working environment, and people are hopefully none the wiser that something was amiss. We'll move on forward with our next launch, which was the Elastic VMware service. I actually grabbed down this excellent article from Sheng Chen, which I'm just going to show y'all here. Just the treasure trove of information that we have just by slowly kind of rolling our way through it. And oh my God, Sheng has a lot to say on this subject.
He dumped his heart out into that article, that's for sure.
I mean, his heart, his brain, his soul, everything, blood, sweat, and tears from user Sheng here over on Repost. So I will provide a link to this. It's actually pretty cool, the use case that we have him going through here. I'm curious, Stanley, were you able to take a look at this article and did it speak to you in any sense?
Yeah, spoiler alert, it is a great article and very practical to get started there. But yeah, it really goes into detail in terms of how you can set up connectivity from if you have VPCs and VMware's environments in different regions or different clusters, how you can bridge the gaps between your on-prem environment as well as different regions while still leveraging VMware in the cloud. So definitely very useful for the individuals who maybe are moving, keep it using the EVS service to migrate over VMware instances and then running those in the cloud. Gives you great details on how to make sure you're able to get to where you need to get to still.
100%. And I love the ability to sort of highlight these things from our community where it's kind of a unique thing that you're going to find here on the Repost page, right? Because you have these users who are going out doing these experiments, finding things that work, finding things that are more efficient or saving cost or saving themselves some time, and then coming and just being like, check out this entire blog, this treasure trove, this tome of information that I've gone out, I've done the testing, and now I'm coming back to share it with you in the community. So I mean, my heart goes out to Sheng. Hopefully you got some sleep. You took a sabbatical after getting published. Great work.
Just a testament to the great knowledge that is to be had here on Repost.
Right. We'll charge forward into DocumentDB serverless, the great segment that we actually just finished. So coming hot off the heels of that, glad that we're able to continue having this conversation. I actually grabbed this question from Errol and I wanted to grab it specifically because it was posted 2 years ago, and they're asking a question that 2 years ago this solution was not in the world for them to actually use and deploy. And so it's nice when we're able to show an example of, customer use case in the wild, and then hey, we listened to you, and then now we're able to provide this solution that's now at your fingertips.
Yeah, absolutely. And here at AWS, we're definitely customer obsessed, and we love to say that we work backwards from our customers to create solutions that fit them and meet their needs where they need them, and to exceed their expectations. So Aeropoler, hopefully I'm saying that right. 2 years ago, they probably got a new username by now, but hey, you asked and we delivered, 2 years later, but better late than never, I always say. So with the new DocumentDB serverless, you really don't have to worry about using Lambda to scale, because you can do that automatically by transitioning over to serverless. And with the recent announcement of serverless, it's actually super easy to switch over to it. You can do it with no downtime, switch over your running DocumentDB clusters straight over to serverless. So you can set, forget, especially those workloads with high spikes, utilizations, peaks and valleys. You're in for a treat with DocumentDB serverless.
For sure. And Aeroper, again, hopefully I got that. We will follow up with links to documentation and link to this video as well in the chat, so that if you are around, if you're still using Repost, hopefully you'll get that answer. You'll be able to start using this today, just because I think it's such a cool service, and I'm glad that we're able to provide that answer for you. That's actually going to bring us to the end of what we have on Repost for today. One thing I would be remiss to not call out, if you haven't noticed, I'm wearing my Seahawks cap. I'm wearing my Sean Alexander jersey. Why would I be doing that? Why would I be repping the NFL? I'm glad that you asked, maybe, hopefully. Next week, on September 4th, is going to be the kickoff of the regular season of the NFL, as the Dallas Cowboys are going to be facing the defending Super Bowl champions, the Philadelphia Eagles. AWS OnAir is going to be there. So follow up the next week. You can see the little lower third graphic down there. September 12th, there's going to be a tailgate party, a big kickoff party for the NFL season. We're going to have a special show here on Twitch. So make sure that you circle on back. And if you're an NFL fan like myself, it's going to be a great time, great show. I know I'll be here.
Hey, Chris, I'm about to reach out. You got the plug for the invite. I need to get in on this, the tailgate. With that being said, that's what we had for you today on Repost Live, a section of the on-air show. Next up, like I said, we're still rolling heavy here for the next half hour. Next up, we're going to go over, we're going to bring on our good friend Darko here to answer the question, and what is event-driven architecture? Over to you, Darko.
Hello, friends. How are you doing? Well, hello there, friends. Hope you're doing well. Welcome. Happy Friday. Happy Friday. And you know what? Today, everybody was talking about football, or I'm from Europe. I don't know what football is. It's the hand egg thing that people throw at people. I've been living in the United States for the last 4 years. I do not know the rules. So I tried my best. I love the Super Bowl because a lot of food and drink and entertainment, but I'm still to choose which my favorite team is. Hopefully Chad can convince me which is the team I should be rooting for. Yeah, football, because you kick it with your foot. There's no hands involved. We call that handball, but that's okay. Set aside that, I know football season is coming up. I think college football as well is a thing here. So, hey, but today people have been talking a lot about serverless and a lot about VMware as well. So I brought out my trusty server here to kind of join me for the beginning of this session. Chris says I should be rooting for the Seahawks. I do live in Seattle, so Seahawks makes the most sense. But is Seahawks the best team? I don't know. Maybe 49ers. That's San Francisco, I'm going to say, I think. Are the Dallas Cowboys a thing? Are they the best? I don't know. Yeah, you fight it out in the comments. I would love to see that. But I'm here for the next 10 minutes to talk to you about event-driven architectures. I want to just cover a little bit from a developer perspective. Why should you care? What are event-driven architectures, and how can you do some stuff on AWS that is event-driven? So I'm going to get my server out of the way because we don't need servers where we're going today, my friends. We're going to be looking at Amazon Event Bridge and some code and events and all the kind of fun stuff we do. Somebody says, just not the Cowboys. Okay, I have no idea. I'm sure that's That's the thing. Do we hate the Cowboys? Are we going to be angry with the Cowboys? I'll be angry with the Cowboys if you need me. Yeah. Oh no, boo Cowboys for a reason. Although I do not watch even the normal football, there's this soccer as well. So like I'm a different kind of sports person. Okay. Jerry Jones hates the Cowboys. Well, there you go. Okay, so I'm going to do a quick thing here because you know what? I don't want to keep talking to you. I just want to show you stuff. So screen is being shared as we speak. I want to share this entire screen. Well, I'm going to ask my friends to pop it up next to me. Bum, look at that. Yes, event-driven architectures. So first of all, let's talk about what are event-driven architectures. Simply put, event-driven architectures are performing certain actions when certain things happen. In a traditional application, when I say traditional, there's a lot of rigidity, right? Process A calls process B, and that could be within the single application. You can have one function call another function, or it can even be a little bit more looser by having one API call a different API. So there are certain separation, but that is very much rigid. Right? You have to make a call to a certain thing. If you want to invoke 5 different functions, 5 different services, you need to make 5 different calls. So what's event-driven architecture? Well, if something happens, do a thing. If an event happened, do a thing. So this is a kind of a way to decouple a lot of things. And I like to use a term here that I learned way back when, and I love that term. It's called, and this is one of the reasons why event-driven architecture exists, at least in part, is graceful degradation. Graceful degradation means basically if certain elements of your application, of your work, of your stack are just busted, something doesn't work, I don't know, image scaling doesn't work anymore, your application will not crash. The whole application will just not die. It will be certainly impacted, certain things won't work, but like overall, everything else will work. So by doing proper event-driven architecture or like decoupling services, that helps out a lot. Somebody's asking me, what do I watch? I was a water polo player, so like I enjoy a lot basketball. I come from Serbia, so basketball is kind of like in law. You have to watch basketball. So yeah. So event-driven architectures, but like beyond just being decoupling, it allows you to have this fantastic way of scaling, right? I'll give you a practical example of an event-driven architecture thing. So I'm going to open up a thing here. Like, look at that. So, there you go. One day I'll learn my own domain. So this thing is my link shortener. It's fully built in the best language in the world in Rust, but it is fully serverless and runs on AWS. So if I go to, I don't know, Wikipedia, and I just take the thing and I want to shorten this URL, hit here, click, that thing that happened right now was not event-driven. That was a direct API call to a Lambda function to shorten this URL. Now, you will see this is the URL I created, but I have this little click counter. This click counter, however, is just showing you how many people visit that specific link. So every time somebody visits that link, that number increases. But that element is event-driven. Let me show you. So I'll click on this link. Look at that. If I refresh here, it's not there yet. But if I keep on refreshing, it's there. Boom, it's 1. So it wasn't immediate. There's some certain eventual consistency. It took a second for it to get there. How did I do that? Well, I was actually monitoring for an event from CloudFront, right? When a user clicks on this link, a request is sent over to Amazon CloudFront, and that request shows up at an event bus. Like somebody clicked on this link. Whenever that kind of an event happens, I have a Lambda function that picks up that event and just +1s this thing here. So if I go and click on it again, come back and refresh in a second, boom, it's 2 now. So it is why did I make this rigid? Well, because here's the thing. Imagine my link counter is broken, an absolutely useless bit of my application, and a user comes here and clicks on the link, and my link counter is broken. All of a sudden, the user cannot get to the link. That's not something you want to do, right? That's a bad way of doing it. So I have it as an event thing, so it can happen eventually, because even if it misses something, it won't miss it. But even if it misses it, it's perfectly fine. So let me show you how you can quickly do this on AWS. So on AWS, there's a service called Amazon Event Bridge. This is basically an event bus. It's a location. There's usually the one called default enabled in your account and in your region, where vast amount of events are sent. Like from an uploaded file to an S3 bucket, which can be automatically an event on this thing, to even CloudWatch events, not CloudWatch, CloudTrail events. CloudTrail events, something that somebody launched an EC2 instance, that event shows up on the bus. So what happens then? What happens if an event goes in the bus? There are certain rules you can create. So for example, if you detect a specific rule happening, a specific thing happening, a file uploaded to S3, or I don't know what they do, like a CloudFront event happening, the rule can trigger certain things. And I'm going to show you this. So I'm going to go into some code. So I have an application here called, well, it doesn't matter, Event event face. And this is a simple Rust application that basically just sends an event into Event Bus. What I'm trying to demonstrate here, you do not have to use native AWS services to send events to the event bus. You can literally just make an SDK call. In this case, I'm creating an event into the myapp.orders destination. The detail is going to be called order placed, and the detail is literally just some raw JSON. It's order ID and customer ID. Simple as that. When I make this call, I'm going to call it in a second, but when I make this call, there is a certain rule I've created here called order placed. This rule basically has this specific JSON here. If you look at this JSON, it looks for a specific pattern of events coming onto the bus. A source needs to be called myapp.orders. The detail type needs to be called order placed, and an order ID must exist in that thing. Anytime this specific pattern is satisfied, something happens. That something, in this case, it triggers a Lambda function. I can basically tell it, hey, listen, a Lambda function, it can be like a Redshift gateway, EC2 stuff, a bunch of different things, right? There's a lot of things that can happen as an event to an event bus. So in this case, I'm just calling this function, and I'm passing the details of that event to the function. So if you see, I have a function here. Let me just make this slightly smaller and go to my latest function. There it is. This function does nothing. It literally just prints out the event to the screen, to the log. So you should do something more here, but as a demonstration. So I'm going to go open up here the monitor, and I'm going to show you the execution of this Lambda function. If I go to the logs, you will see that there is a single log entry here, just a single log entry, because the only single things has been created, right? So I'm going to go back to event phase and cargo run. This should send an event over to the event bus. So in this case, you see that I've sent an event. That's it. Nothing special. Event is there. However, in a second, this event is going to trigger the rule that's going to trigger this Lambda function, right? So if I go and refresh my logs, look at that. Already triggered, right? It's decoupled. There's no rigidity here. The Lambda function did not have to run, but it did run. And if I open up the log of the Lambda function, you will see here, oh my, CloudWatch doesn't really like being zoomed in, doesn't it? Let me do this. Slightly better. You will see here, there's the event. Order placed, source, account, here's the details of the order, and that's it, right? You can imagine doing something actually with this thing. So my friends, if you want to get started with some event-driven architectures, Amazon Event Bridge is your friend. It's a service that you can use. It's probably already enabled in your account. It's probably there. It's probably running. You probably even have a bus called default. So check out the SDKs. The simplest way you can start working on it is literally upload a file to an S3 bucket. That thing should show up as an event in the event bus if your bucket is configured. I'm going to leave a link to this to the YouTube channel called AWS Developers. We do have a bunch of serverless data content there. Go check it out. Why is this thing important right now? Why should you now listen to me and do event-driven architectures? Because you are all my vibe coder buddies. Hey, Zoomers, we all like to vibe code. And it's better to vibe code microservices than a big old monolith. So, yeah. Okay, Friends, I'm going to go and answer the questions in the chat if I can, because my time is up. I need to give up my time to somebody else. So chat, I see a bunch of things here. Beautiful. Okay, excellent. Chat, thank you so much. I'm going to give you back to the rest of the on-air team. Happy to be here. Looking forward to the next one. Bye.
Wow, we got a much needed break here, Jeff. Just the hydration and energy we needed to close out our final segment here with a really powerful customer story, thinking about as you think about this proliferation of agentic IDEs and just making it easier to code, not just in a sandbox, but with real enterprise infrastructure and applications. The ability, as Resolve AI says for themselves, machines on call for humans. Nobody better than Manveer here to comment on the unique way that they're using agentic AI, Amazon Bedrock, and beyond. Welcome to the show, Manveer. Excited to have you.
Hey, Robbie. Awesome to be on the show.
Can you tell us a little bit more about Resolve AI and maybe the origin story? I know you were the founders. Many of the folks in your company come from open telemetry, so you've lived and breathed the observability world and the pain that developers and SREs can face when they get paged in the middle of the night to go solve something immediately. No context. I got to dive in. How did you stumble upon the statement? How to Resolve AI get it started?
Yeah, I mean, that's a great question, right? Like, if you think about the origin story, and like this is all documented on the website as well, like for the last several years or decades, really, it's all been about more and more data being like served up to engineers about how do you think about troubleshooting your production environment. So you got more dashboards, more traces, more logs, more metrics, and more of all this, but the toil was always left on humans. So as we look at the founding team, that the co-creators of Resolve AI, they've actually been working together for over 15 years across multiple different endeavors that have led them to Splunk, to VMware, co-founding 2 additional companies that were acquired by those vendors, co-creating open telemetry. And it wasn't until at Splunk that they thought they were done with this startup adventure. They're like, there's something different here about what AI promises. And it was really the limitations of their own imaginations that was like, hey, we don't have that the imagination is there. Now the tooling is finally there of how do we rethink what does it mean to manage production systems? What does it mean to go on call? What does it mean to manage those war rooms? Yeah, so like the founding story for Spiros and Mayank, so those are the 2 co-founders of Resolve, is definitely one of like just living the toil and that grind for several decades and finally coming up with a solution that's solving the pain for engineers everywhere.
Yeah, Manveer, it sounds like you have a demo for us. I kind of want to see what Resolve AI is doing, and let's talk about it while you're showing us.
Yeah, happy to. So if the demo environment's up today, so what you can see here is that Resolve offers 2 experiences. I'm going to start here from the UX because I really want to ground of like what Resolve is and how we work, and this is going to be important for setting the stage later. But ultimately, as you think about a multi-agent system, so this isn't an LLM wrapper, this isn't some RAG system. We're not just doing a single MCP call. This is truly a multi-agent, multi-model system that's been built on being able to do a couple of things. One is understanding your production environment all the way from telemetry traces, so your observability data, down to infrastructure and code. It's a system that's also designed to reason, right? Just the way humans reason through complexity and toil, same way. Take action on being able to figure out what the remediation plan is, invoke other tools to get the process started, and then continuously learn, which is probably the hardest thing to do and also the most important aspect of this as well, right? Is like, how do you engage that learning? So the way we approach this is really just to kind of bring you through when people are getting set up here. So let me just kind of pull up the knowledge graph. This is kind of like, think about the backbone or the brains of kind of what sets the stage for everything else. So now this isn't meant for human consumption. Like, I don't think there's a single person out there in the world that knows their end-to-end production environment from scratch. But you could imagine this is one production system, and the amount of dependencies and like everything that if you drill down to like the node level performance, like that's all documented here. And in this particular, and we'll come back to this, but in this particular environment, like what we're doing is from the integration standpoint, it's to set up on Datadog. It's a DNS tap that we've done. We've also integrated GitHub and then Kubernetes as well, right, with Slack in this particular kind of environment that we've done. Now, there's other integrations and services that are available, like how do you get into AWS, to Atlassian, and Grafana, and others. But for this particular setup, this is what we have configured here. So if I go back to that knowledge graph,
so
go ahead. Yeah, go ahead.
That knowledge graph is of like of a workload per se. So are those all microservices?
Yeah, so
Or-
these are your so these would be like microservices. Like this, in this case, this is like the consumer checkout, like the checkout cart, what we have here. So if I were to just click into the front end proxy, right, as an example, what this does is then it allows me to map out all the interdependencies within the environment itself, right? So that's extremely powerful because most humans, unless you're working on your individual microservices or a set of services that you wouldn't have this level of context if you're the one going on call that night and something else breaks.
Or if there was like this, if this was mapped out previously, it was maybe mapped out like maybe 6 months ago before things changed and it's out of date and you're looking at old documentation. So I've been there. So
yeah, I mean, 6 months is, I think, even a week, right? Like nowadays, it's like you're pushing, like as well as Darko was saying, your vibe coding, like code is changing so frequently. Like it's not even about 6 months, or it's like the changes that are happening on a weekly or the daily basis. So one thing that I'll call out here before we kind of go to the fun stuff is really the ability, what I talked about, the learning, right? So over time, with every engagement, with every incident, or just me coming in here and helping to improve the knowledge base, the agents become smarter and smarter and more attuned to your specific environment based on those interactions. And so they're always learning and retaining that in the form of memories. So that becomes super powerful. So that way you're not having to kind of retrain it every single time that it's going back on call. Like it just goes on call and it's almost like self-improving. So with that, let me go ahead and jump over to like what this would look like from a user experience for folks, right? So a couple of ways, right? Here in this case, we have our alert system set up. This is me in Slack right now, so this is like fully in production. So if it does stall a little bit, or if it's having to think a couple of cycles, this isn't a stage environment. This is like fully running in prod for like a live demo scenario. So I'm just going to come in here. This trigger was fired today around like 12 p.m. 12 p.m. So right while this show was going on, Resolve immediately came in, acknowledged that this issue was triggered, goes back and starts doing this initial like investigation, right? Of like, what do I think is happening in the top findings that are coming here? So in this case, it was a front end P50 latency for post API checkout exceeds, right, the threshold starting point for approximately at 1901 UTC. So what is that, about 701 roughly, right? If I get the military time right. I think that's about right.
Real quick, P50 was probably like the 50th percentile. That's sort of probably how you configured this alert to trigger if latency goes above the 50th percentile. Just make sure.
So that's 100% right. So it understands the context of what the parameters that were set. And then it's like, okay, hey, this did get triggered. The alert was triggered. So we're not in the alerting business, but the alert was triggered. We come in and start getting into the triaging and then the investigation portion. Yep. But you start understanding, because it has that knowledge of your production systems and whatever tribal knowledge was loaded at the start and it's learning over time, it starts running almost like, these are the multiple hypotheses that I think I want to go test based on either known experiences, what I have context on about these types of incidents, or just kind of where the alerts were starting and then any dependencies that it may have had. So ultimately it does this. So, and then quickly right after, it comes in with this most likely working theory. And once again, this is all being showcased in Slack, and I haven't even left a Slack experience, right? And so most of the, if you think about most of the initial debugging during incidents or war times, everybody's scrambling through their Slack experiences or Teams or what have you. And so finally, if I want to get to a point where it's like, okay, I want to dive in deeper, I want to see what's really going on or figure out how the remediation plan is, then I'd come over to the UI. And this is where I could start, and I could also engage with Resolve in Slack as well. So just at Resolve and like continue the conversation there. But if I want to start seeing today, like at least more of the details, all the evidence that's being surfaced up, because it understands the pool. So it's not just a black box experience. It's going to surface up the evidence. That's where you'd come into the Resolve experience here. So in this case, right, so you see the dashboards is pulling up. It's reading those dashboards. It has a good understanding of what are the relevant dashboards here. Came back with the working theories that you see here as well, right? So multiple downstream services were performing degradations. And then here's the evidence if I want to dive deeper. So in this case, it's a 391 Redis connectivity error logs occurred. It continues to provide that granularity that you would expect and you would normally have to go find on your own. And if I continue to go further down, and this is all just the investigation that is served up and came back within minutes of the alert firing, right? It actually goes and sequences out the timeline as well. Go ahead.
Manveer, what's funny, what you just showed, this kind of output is what you typically see at the end, like 2 weeks later, after a full performance review has been like, this is what happened 2 weeks ago. We took a long time and we figured all this stuff out. And you said this is able to pull this stuff very quickly.
It is. It's very, I mean, you're spot on. So this is very quickly, within minutes. So typically in most cases, we'll see from triage to complete investigation with evidence in about 5 minutes, right? And you're spot on. That would normally, if it's like depending on the severity of the alert or the incident, if it's it's an outage of some sort, obviously it's all hands on deck. But other ones, like step 1, step 2, like you may not prioritize it as much, and that may take longer. But this is definitely, how do we get to that? How do we enable engineers to start fixing faster versus just trying to figure out what went wrong?
So how do things like enterprise guardrails or human in the loop integration look like? Do I have to accept some changes? Can I put guardrails on what changes need to be accepted by me versus automatically remediated?
Yeah, so that's a great question. So today we're not in the remediation business yet, right? So it's all about how do we actually reduce that toil or eliminate that toil of actually figuring out what went wrong. Now, can you imagine in a couple of months where we're within those guardrails or predefined types of activities that Resolve can take? Is that feasible? Very likely, right? And so what an example could look like is like, obviously rollbacks are very safe, right? So especially during when you've done a new release, and like, hey, that issue was caused by the release. There's high confidence level. You have all the evidence to support it. Then go ahead and do an automatic rollback to the prior version. So that could be one that's within these predefined guardrails. And we're hearing customers actually becoming, I think if you were to look back even 6 months to a year, there's probably a little hesitation of AI taking action on behalf of humans. And we're getting to a point where now it's like our customers are asking us, got that Slack notification going on, that customers are actually asking us like, hey, can you take action within these predefined guardrails for us? So, and then your second question about the human in the loop, at any given time, whether it's in that initial Slack experience or here, I, as the engineer or anybody who's investigating this, could just take control and start diving deeper. So here, like I was going to start asking to just understand if there's other dependencies, right? Just as an example, dependencies that show elevated error rates or resource saturation. Apologies for the spelling there. Trying to do this quickly during the front end checkout latency spike, right? So it's going to go churn its wheels. Hopefully this does it quick. Like I said, it's going, but you see the investigations going. There's everything's kind of working in the background. But this is, so, okay, I actually did that fairly quickly. So you kind of come back in here and you see like, hey, during the front end checkout latency, right, there were definitely downstream dependencies that were impacted. And this is where like the additional magic of all this starts to come alive, where I could actually ask like, hey, what's the remediation plan, right? And what's the fix? Write a PR, create a postmortem, right? All these things that normally is like on the burden of engineers to go do. It's like, how do we remove that toil off their plates, right? So they're focusing more on building versus this firefighting mode that they get distracted with.
Got so I've got 2 questions for you. We are live with thousands of builders tuning in, and I want to take some questions from the audience if that's okay, Manveer. People are super excited, and
yeah, bring it on.
I want to. First question that we got is about root cause analysis. So there's a GVO Cipher says. So how does root cause analysis play a role, and in what order of the sequencing is Resolve AI using that?
Yeah, so like obviously root cause, right? If you think about it, for even humans today, it's an extremely difficult thing to do because you're, and most likely the default is to go figure out like, hey, these are the known symptoms that I know, so it's my tribal knowledge, and I know it's likely here, but that may not be the true cause of things because there might be some downstream dependency that's caused the theory. So I think everybody in the space, including Resolve AI, we are aggressively working towards improving the root cause and getting to the highest confidence level. But the goal of all this is to actually get to root cause, right? So there is high confidence, all this stuff. So in this case, we're framing it as working theories. But if you were to go further down in here, like it's actually the most probable cause, right? We're actually, saying without saying root cause, like, hey, this is your root cause, like very likely it's either one of these incidents, this incident, or the multiple downstream service performance segregations that were causing this issue. So, but you can imagine like it's very much about getting towards root cause.
And we have one more question from that same individual around. I mean, it's clearly this is resonating. If we're already getting questions around, how much does this cost?
Yeah, contact us is the best way to put it. Right now, like, I don't think it's not publicly pricing available, but I would say the best way is just to contact us, and we could see what that means for your particular environment and everything else. So I just want to wrap on this. I know we're coming up to time on your guys' end, but you see it's gone through, came back with a fix. I could even go ask next if there's like code issues or code related fixes. Generate the code for me, and if I wanted to at that point go to a coding agent and like do all the magic with that as well from here. I know somebody mentioned vibe. Darko mentioned vibe coding. The other aspect of this is all about real time production incidents. Like the fire is active, but how do you also go proactive? And we call it as vibe debugging. And like an engineer is just coming in and it's like, hey, you know what? Customer is saying that there's might be some performance issues. Can you tell me what's going on? And just simple prompts like that using natural language to understand what is happening in your production system is the other aspect of Resolve AI as well.
Yeah, I was going to say Vibe Ops. How about that?
Yeah, Vibe Ops. I don't know. We'll see which one we can make happen. But if that's not a coin term, then we'll take it.
Or chaos vibing. How about that?
Yeah, I don't know. Let's pull that one with the audience. That's what I'll say.
Cool, man. Veer, this is really great. I wish we had a little bit more time, but thanks so much for this demo. It was really interesting. Excited to see Gen AI and all of the agents, and we're just seeing new, like, you're limited by your imagination. So it's like, oh, do some research and everything. But now we're seeing like anyone in IT who just saw your demo can relate to that somehow, whether it's, like trying to figure out what happened, root cause analysis. But I could just see, while that might not be the real root cause analysis, it's a good starting point where you have no starting point when, it's 3 a.m. and you don't know what to do. Those look like really promising starting points. And
100%, right? You're not in an empty maze anymore, right? Yeah. Or, a needle in a haystack. Like you have direction, and then the root cause, like you're just going to see that improvement getting better and better, and the accuracy rate. And like, we're definitely leading the charge on that. So cool. Yeah, but thank you for the time, guys.
Thanks, Veer.
Thanks. All right, Robbie, some really good stuff today, man. Way to end out the week.
I couldn't have asked for a better episode. I couldn't have asked for a better co-host. And if I did my math correctly, we had 8 segments in 2 hours and 1 minute and 22 seconds together. We covered everything from the most primitive of bare metal and virtual machines all the way to serverless and what did you call it? A vibe opsing. There's so much that we can cover in such a short episode, and it really shows the breadth and depth of services that AWS has to offer.
We talked a lot about resilience and some blue-green deployments, and even Jeff Barr with the fault injection simulator. It was again, I'm going to say it again. I said it like 4 times throughout the whole episode. All these choices for the AWS customers to do things the way they want to do and to achieve those best practices. It's just really cool to learn about.
Absolutely. And alas, this is our last weekly on-air episode of August, but we continue right ahead into September. And our first episode, this is a special one, a unique collaboration with NFL, all things football. You want to tell us a little bit more about that, Jeff?
Yeah, it sounds like the AWS OnAir folks are going to be at this game to kind of talk about how AWS is helping. I mean, you see a lot of those commercials, things of that nature, which is, by the way, how when people ask what I do, non-IT folks, so I work for AWS. Have you seen that NFL commercial, stat that? That's how I try to kind of get them involved. But it sounds like our viewers are going to learn a little bit more about how AWS is working with the NFL. So that's very exciting.
Live from Philadelphia, and one of our co-hosts, Todd, is going to be there live. I think my invitation must have gotten lost in the mail. I'm okay with it. It's cool. It's whatever. But for all of our the audience tuning in with that survey, if you want to put in the comments that you would have liked to see me live in Philly, that would be okay. I'm sure the same with Jeff. But no hard feelings either way. But alas, our time has come to an end. Jeff, take us home.
Yeah, everyone, thank you for tuning in. We do this every other week now, this 2-hour episode. Robbie, thanks so much. To all of our production team, thank you so much. Debbie, our wonderful producer, who is not Nick, who's a lot better than Nick. Debbie, it's always a pleasure. And to all of our guests who took time out of their day to join us and share some of their demos, some of the new features. Thank you to Jeff Barr for coming out and showing us some new cool things, some outstanding compute stuff that's coming around. So thank every one of you for tuning in, and we'll see you next time. Robbie, anything else?
Just my favorite way to close. Work hard, have fun, make history, and we'll see you next time on AWS On Air.
We'll see you.